This video will be the third part of nomenclature of alkane that will focus on naming our cycloalkanes. The next compound that we're going to look on is in the family of alkane, which is cycloalkane. So we're going to look on how to name our cycloalkanes. So for the nomenclature of cycloalkanes, we have the prefix cyclo, parent and suffix. So it's similar to naming the alkanes. The only difference is we have the cyclo part over here. Why do we have cyclo? Cyclo represent the ring over here because we have a cyclic structure, so we name it as cycloalkane. So if let's say I have a 4 cyclic alkane, 4 carbon, so I will name it as cyclobutane. If I have 5, so it will be cyclopentane. So that will be the parent chain. If the number of carbon atoms in ring is equal or greater than the number in the substituent, the compound is named as cycloalkane. So for example, this one. If only one substituent is present, so no number is needed. So for this part, what does it mean? So I have the cyclic structure over here and I have the substituent. Let's count the number. So for the cyclic structure, I have 1. We have here 1, 2, 3, 4 and 5. 5. And then the substituent is only 1 carbon. So that means this will be our parent chain. So the parent name will be cyclopentane. And then over here, if only one substituent is present, we don't need to number the alkyl group over here. There's no need to number the methyl. So straight away, we can name the structure as methyl cyclopentane because whatever it is, this will be number 1. So there's no need to put a number over here. Still under this criteria, if number of carbon atom in ring is equal or greater than the number in the substituent, the compound is named as cycloalkane. But if, let's say, I have this structure, so this is our cyclic structure, 3 carbons, and then the substituent, so-called substituent over here, have 4 carbons. So the linear chain is 4, the cyclic is 3 carbons. So automatically, the one that will be chosen as the parent chain will be the 4 carbons over here. So what will be the name of our alkane here? So since the parent name is butane, 4 carbon, so if our cyclic structure over here, 3 carbon, if it's an alkane, we call it as cyclopropane. But since it's a substituent, so we call it as cyclopropyl. And we need to put a number here to show that this substituent, the cyclic substituent over here, is attached to the first carbon. So that's why we name it as 1-cyclopropyl butane. When the compound contains important functional group, so the cyclic portion is sometimes named as cycloalkyl substituent. So our alkenes, our cycloalkane over here, it does not have any functional group. So in the presence of other functional group, the cyclic structure will automatically become a substituent. So for example, like this. So if you look over here, we have a functional group of carbon-carbon triple bond for alkyne. And then it's located at carbon number 1 and carbon number 2. So we have a cyclic structure over here. So automatically, this cyclic structure, this cyclobutane will become a substituent, and we call it as cyclobutyl. So the name for this compound will be, so the parent is 1-pentyne, 1 because the carbon-carbon triple bond located at carbon number 1 and carbon number 2. So we take the lowest number, 1-pentyne, and then at the 5th carbon over here, we have this substituent, the cycloalkanes, which is 5-cyclobutyl. So the name of this compound will be 5-cyclobutyl 1-pentyne. So, cyclo is considered part of the alkyl group name for alphabetizing purpose. So, meaning, okay, if we have a structure over here, so, okay, this is the parent chain. So, here is our substituent. So, at carbon number 1, we have both here, methyl, okay, and then at carbon number 3 over here, we have cyclopropyl. So, for alphabet purpose, okay, C and M, you will choose between C and M. So, the word cyclo itself is included as part of the alphabetical order. Okay, so that's why when we are writing down the name, okay, so the parent name will be cyclohexane because we have 6 carbon over here, and then we give number 1 to this carbon because it has 2 substituents. It has the most substituent. Okay, so CH3, CH3, so that's why this is 1. And then the lowest possible number is 1, 2, and 3 over here instead of the other way around. So that's why we have here 1,1-dimethyl, okay, and then 3-cyclopropane. So the naming considered as C. C comes first and then M. So that's why it's 3-cyclopropyl 1,1-dimethyl cyclohexane. When 2 substituents are present, so we're going to number the ring so that the second substituent has a lower number as possible. So, for example, this one. So, I have a cyclohexane over here and we have 2 alkyl group. So, methyl. Okay, so let me just label this. So, this is methyl. Okay, and then this is methyl. So, actually, we have 2 possible numbering. Okay, the first one is this one. Okay, the one that is stated here. Okay, where this is number 1, 2, 3, 4, 5, and 6. Or the other one, it will be like this. Okay, this is number 1, 2, 3, 4, 5, and 6. So, if you look over here, why do we choose the red color one instead of the blue color one inside? It is because the red color one will give us the lowest combination number, okay, which we have over here 1 and 3. Okay, sorry, let me use the red color. Okay, 1 and 3. Okay, compared to the blue color one, the combination, the number combination that we will have is 1 and 5. Okay, the substituent is the same, it's methyl, but we need to choose the lowest number combination as possible. So that's why, okay, we're going to choose 1 and 3. So it will not be this one. Okay, so we can erase this. So that's why the name of the compound, so the parent name is cyclohexane. The substituent is 1,3-dimethyl. Di over here because we have 2 methyl group. So to write down the name, it will be 1,3-dimethyl cyclohexane. Now, how are we going to name a cycloalkane when 2 different substituents are present? Okay, so number the ring by alphabetical priority. So just now, the one that we did, we have 2 substituents but identical substituent. We have both methyl. Now, look at this example. So I have a cyclohexane over here, but I have 2 different substituents. So I have over here is methyl, and then over here is ethyl. Okay, so we're going to number our cycle over here, okay, based on alphabetical order. So E comes first and then M. Okay, so that's why we put number 1 at E. Okay, so automatically ethyl over here we have number 1. And for the numbering, do we need to do it anti-clockwise or clockwise? So we choose it this way because, okay, we actually have another combination, okay, which is 1. So this is 1, 2, 3, 4, 5, and 6. But the combination in the blue color will give us a bigger combination, 1 and 5. The red one will give us 1 and 3. So that's why we did not choose the blue color over here. So as for the naming, okay, the parent name is cyclohexane. The substituent, we have here 1 ethyl, and then we have 3 methyl. So the naming will still follow how we name our alkane. So it will be 1 ethyl, 3 methyl cyclohexane. How about when we have 3 or more substituents present? So for 3 and more substituents, begin at the substituent that leads to the lowest sets of location numbers. So we don't choose by the alphabetical order, but instead we try to find the lowest combination of number. If you have 2 substituents, yes, you will choose by the alphabetical order if it's different. But if you have more than 2, you have 3 and more. So we choose the lowest possible combination. So for example, this one. So I have here 3 different substituents. Okay, so the name of the substituent over here, first we have here our propyl. Okay, this is propyl. This is methyl. And then this is ethyl. Okay, so by right, if we follow the previous step, okay, we will put the first number on ethyl. Okay, why? Because ethyl is E. Okay, E comes first before P and M. Okay, so let's say if we put E first, so 1, 2, 3, 4, 5, 6. So the combination that we will get is 1, 3, and 4. Okay, but like I mentioned before, this is not the case. Okay, because when we have 3 or more substituents, we need to find a number that will give us the lowest possible combination. So the lowest possible combination is the red one over here, where we have 1, 2, and 4. Okay, so between these two, which one is lower? 1, 2, and 4. So that is why we did not choose the blue color 1, 1, 3, 4 over here. This is not our number. So it will be as stated at the picture over here. Okay, we will have 1 propyl, we will have 2 methyl, and we will have 4 ethyl. But for the purpose of writing down the name, still we're going to name it alphabetical order. So the parent name cyclohexane, substituent 1 propyl, 2 methyl, 4 ethyl. So since E will be the first alphabet among these 3, so it will be 4 ethyl followed by 2 methyl, 1 propyl, cyclohexane. With the last example, we have come to the end of naming our cycloalkanes and also the end for the nomenclature of alkane compounds. So thank you for listening very attentively, and until we'll meet again in another video. Goodbye.